Hello everybody, welcome back to Med School EU. My name is Andre and today we're going to be doing another educational video on chemistry from the IMAT specifications. Today the topic will be inorganic compounds and we're going to take a look at their properties, more specifically the properties of oxides, hydroxides, and acids. Let's begin talking about oxides and what they are and their properties. Well, oxides are defined to be chemical compounds with one or more oxygen atoms. And they will typically be binary compounds. And binary compounds are basically when you have two different elements involved. So you've got some sort of element, whether a metal or a non-metal, and an oxide. So binary meaning that you have two things, one and two combined together in one compound. Now, some examples of oxides would be lithium oxide, Li2O, carbon dioxide, sulfur dioxide. We have calcium oxide or water, H2O. These are all oxides because they simply contain an oxygen atom in them. Now, because they contain this oxygen atom, they will be called oxides and they will exhibit specific properties. One of the most important things that we have to know about oxides for the exam is we have to know which oxides are acidic in nature, which oxides are basic in nature, which oxides are amphoteric in nature, and which oxides would be neutral in nature. Let's first discuss the properties of acidic oxides. They're also commonly known as acid anhydrides. Now, they will follow a general equation scheme or chemical equation scheme of non-metal oxide that will bond with water. So non-metal oxide dropped in water will result in an acid. This is how acids would be formed. So as an example, we could use SO2, right? Non-metal, sulfur is a non-metal, oxygen is a non-metal, so it's a non-metal oxide. And water is going to form sulfurous acid, so H2SO3. This is called sulfurous acid. And if you are wondering how I just came up with the name sulfurous acid, you should check out the video right up here at the top to learn inorganic nomenclature. Now, when I take this sulfur dioxide, SO2, and I'm going to combine it with a base, so something like NaOH, then the result is going to be a salt and water. So Na2SO3 and water. So this forms salt and water. Whenever we have this type of arrangement, we know that this is going to act as an acid and this will act as a base because the general neutralization reaction is acid plus base that results in water and salt. So when this occurs, you know that you're dealing with an acidic oxide. So non-metal oxides will make an acid and they will be acidic in water. Moving on to basic oxides, commonly known as base anhydrides. So metal oxides are going to be the ones that will form bases when dropped in water. So metal oxide plus water will form a base. For example, if we have magnesium oxide, MgO, plus water, we know that we are going to form MgOH. So metal oxides are generally going to be the metals that will bond with oxygen from groups 1 and group 2. So your alkali metals and alkali earth metals are going to be the ones that will exhibit these properties. Now, when we're reacting them with acids, so when you have a metal oxide that will react with acid, it will again form a salt and water. And the reason for that is, again, because this is just a neutralization reaction, since metal oxide is going to act like a base. Now let's talk about amphoteric oxides. And the word amphoteric means substance that can react as an acid or a base. In order to really know what this means, we also have to know what is an acid and what is a base. So this is also going to cover that part of the specifications where it talks about acids and their properties. So to identify what is an acid and what is a base, there are two specific definitions for that. So we're going to learn about those definitions first, and then we're going to circle back to the amphoteric oxides to cover some examples. First, we will discuss the Arrhenius definition of acid and bases. So according to the Arrhenius definition, an acid is going to be a substance that produces a proton or a hydronium, H3O plus hydronium, a compound, in aqueous solution. And the definition of a base, according to Arrhenius, is some sort of compound that produces hydroxide ions in aqueous solutions. Now, Arrhenius' definition is no longer used in modern science. So instead, we came up with a different definition called the Bronsted-Lowry definition. So let's talk about that one next. So the Bronsted-Lowry definition is a little bit simpler than that. So an acid, according to these scientists, is going to be a proton donor. And bases, so a base is going to be identified as a proton acceptor. Now that we know the two definitions, and these ones are the ones that are typically used to this day, we can now establish what is an amphoteric oxide, since it can be both acid and a base. So, for example, if we have an acid, HCl, and water, in this case, the water will be in a situation where it will have to act like a base. So what we're going to produce is H3O plus and Cl minus. So in this case, this would be the acid, and water will have to be the base. And it's the base because it's going to accept a proton. As you can see, the water accepts a proton, whereas the acid donates a proton and now is left with just a Cl minus. Now, in a different scenario of NH3, for example, that will react with water, we are going to get NH4 plus ammonium and hydroxide ion. So in this case, as you can see, the water is going to be donating a proton, so it's going to act like an acid. And of course, NH3 is a base. So when it acts like an acid, it's going to get rid of a proton and will remain as an OH minus, whereas the NH3, the base, will now accept a proton. Next, let's talk about hydroxides. And I mean, hydroxides is the OH minus. So we've already discussed this in multiple formats. So hydroxides are essentially going to be forming bases. So they form bases when they react with metals. And some of the strongest bases that will be formed is when the OH reacts with an alkali metal. So as an example of some alkali metals that form strong bases, is going to be sodium. NaOH is a strong base. LiOH is a strong base, KOH is a strong base, and so on. So there's going to be 6 strong bases, and most of them will be formed from the alkali metals. Now, a couple of properties of hydroxides, since they are going to exhibit bases, they're going to taste bitter, so bases taste bitter. They're going to feel slippery. So if you ever grab detergent is a base, is a classic base. It's a strong base as well in most cases. So if you grab detergent, you put it on your hands, it's slippery. And if you taste it, it's bitter, which I don't recommend. And of course, some of the most notable properties, which we already discussed, is that it causes a neutralization reaction with acids. So it neutralizes acids. Now, since we already talked about acids and some of their properties and what is the definition of acids, we could here talk a little bit more about their properties briefly. So acids are going to be based on the formation of hydronium and proton ions. And essentially, they are going to taste sour rather than bitter like bases. Another notable property is it's going to dissolve metals and release H2 gas. And of course, they're going to neutralize bases. Another concept that we do have to know about acids and bases is going to be pH. And pH is going to be the measurement of the concentration of H plus ion inside the aqueous solution. So the more ion you have, the closer it is going to be to 0. The more proton you have, the closer it's to 0. And the less proton you have, the closer it is to 14. So 14 is going to be categorized as a base, and closer to 0 is going to be categorized as an acid. And the closer it goes to 0, the stronger the acid. The closer it goes to 14, the stronger the base. And exactly in the middle at 7, we're going to have a neutral compound. So for example, something like we talked about with the carbon monoxide, or even water. Water is amphoteric. Yes, it has the property to be both. But if water is just on its own, it's going to be neutral at pH 7, if it's purified water, of course. This concludes our lecture for today. Click on the next video to learn more about the properties of acids and salts.